Just about drunk it all. I haven't even started talking. Well, I've been talking.
Welcome to the meeting, everybody. This is the February meeting of the Inventors Association. And we are going to have a guest here tonight. It's Graham Hartland.
Yes.
And he's going to be talking all about this microscope stuff. And it's going to be very exciting because it's right down deep into the healthiness of the air that we breathe, isn't it, basically?
It is, and it's got a lot more applications than what we've originally put it to marketing.
And before we get into that, I'll just let everyone know that the toilets are just out the door and to your right and next door. And then if there's a fire or some problem, the alarm will probably go off and we exit via either the front door and we go out the back. Just follow the signs. We're hoping there's not going to be any experiences like that tonight.
Don't go out the windows.
Yeah, that's the last resort. If everyone could turn their mobile phones off or to silent, that would be great. I'll do my own. And when the meeting's finished, we just have supper down the road here, and Sasha supplies all the chocolate biscuits.
There's
All
there's a variety of
all that
biscuits.
sort of stuff, yeah.
Stuff.
And there's tea and coffee to have and all sorts of things like that. So, and then what we do, we finish just before 10. We've got to be out of here at 10 or just before. So that's all good. So we've got new visitors tonight. We've got Kent.
Jai.
Jai. I think you've been here once before, haven't you, Jai? Yeah. Okay.
First time?
Excellent.
Kent, did you fill out the little green visitors form?
Yeah.
What's your surname?
I'll give you all that stuff. Or do you want it now?
No, not right now. Anyway, about the visitors, unfortunately we haven't got our visitors payment system worked out yet. After the meeting, if you could see Marie and Brian, we'll get that organised for you. Pay you a bit of money. That'll be good. I don't think there's anything else. Oh, any apologies tonight? No apologies? I didn't get any.
Didn't get any?
No apologies. So without further ado, hand over to Graham.
Okay. I'll give you some more water.
Oh, thank you very much. Look, thank you very much for the invite and having me here, and thank you to my old friend Sasha for asking as well. Sasha and I used to serve on a board together for about 10 years or something.
Way back.
A long time ago on a non-for-profit board. Okay, so I'm Graham Hartland. I call myself the dumb electrician. That's my only formal qualification in life. What we're going to talk about is Frontier Microscopy. Frontier was a thought bubble by a guy named Jordan Gruber in early 2016, probably about January, February 2016. He and his brother were sitting down talking one night. His brother is an analyst that does this for a living. That goes and counts all these little fibres under the cells, and looked about all of the frustration of what that was for him in doing his job, talked to his brother about it, and like anything, thought he'd try and solve the problem. World Health Organisation, and this photo was taken last year in Manila, where Jordan and I both presented to the World Health Organisation and the United Nations Environmental Forum on asbestos-related diseases and illnesses. In fact, we're talking again there for them in Thailand in a couple of weeks' time. As you can see, they're phenomenal numbers. That's nowhere near accurate from their own records of how many people are exposed and how many people die every year of asbestos-related illnesses. We still, believe it or not, they're still being produced, they're still being installed on greater volume than it ever was when we banned it. There's still more tons of it going into buildings, and very few countries have actually banned it. So we're actually leaders in this forum of what we're doing about banning these contaminants. For those that don't know, asbestos is not a man-made product. It's a natural fibre that you find in the ground. Now you can go in the ground and you can pick up this ball of fluff out of the dirt, and that's asbestos fibre. So it's a natural substance that's found in the dirt. And they do not add anything. All they have done in the past is added it to products with concrete and other materials, but as a product or as an item, it is a natural product found in the ground everywhere in the world. So it's not going away. The world or the earth is still making it. It will always exist. Okay. Currently, the process is minimum 3 to 5 hours of doing an air sample. So they put an air filter on there with that drags air through a filter membrane, a little bit of cloth, and fills up the cloth. After 5 hours, they take that bit of cloth, cut it in half, put half on the microscope, and then see what's under there. Then it takes and turnaround time in typically it's about 3 days for that part, and then it takes at least 2 hours to compile the report and count the fibres and that. Our current regulations in Australia, and there's only really 2 in the world, requires you to count 100 fields of view of the fibre on the microscope. There is just over 5,000 fields of view on half a filter sample. By law, we only have to count 100 of them. So the acceptable error risk is extremely high, unbelievably high.
So why do they bother monitoring?
Regulations based on the ability of humans and for economic outcomes. If someone had to count the just call it 5,000 fields of view, it would take one person all day to analyse one sample. On a typical job site, you need to do a minimum of 5 samples in any one day. So that would mean 5 people would take all day to count every grid line, and that's all it is. Just think of a grid paper, and it's just the grids, and you've got to count how many fibres are in that grid, and if they're the right type of fibre. So it could be wool, it could be cotton, it could be any other type of fibrous substance could be blowing around that site other than asbestos, but it can also have asbestos on there. And you have to determine what it looks like, its characteristics, count it, see how many of them are in every grid line. And we're talking microns. So each one's only microns. So it's a hard job for an analyst. It strains their eyes. Legally, they're only allowed to do 12 samples a day per a person because of eye strain, fatigue and wear and tear of making sure that's right. So what Marvin is, and we called it Marvin, and if anyone's ever goes back to the days from Hitchhiker's Guide to the Galaxy, Marvin was the robot in there that didn't like aliens. So Marvin's the robot that doesn't like asbestos.
Paranoid android.
So it's the paranoid android, exactly right. So that's where the humour came from one night, sitting up in, I've forgotten the name of the first co-share place we were in. Majoran.
Yeah.
We were sitting up there one night and we had this stupid discussion that we had to name it something, and it either had to be feminine or masculine, and Marvin came up.
Wow.
So it's not an acronym or something?
It's not an acronym, it was just purely 3 people being really silly over a few beers.
I like it.
So that's how Marvin came up, and we just said it had to be fun.
Yeah.
And that's how it became fun, because it relates to the Hitchhiker's Guide to the Galaxy. Bit hard to see with the slide. Sorry, Sasha, I'll just turn this off for a sec. Okay, so that's what you can see with the asbestos fibres when we're doing the count. Those lines what we're doing is we're taking and breaking down the fibre from reflections and looking at the rayons, so how light reflects off of a fibre. So every fibre reflects light in a different way, in a different manner. So that's one of the elements. So we identify it by how it reflects light, then we identify it by size, and then we identify it by its physical characteristic traits of how many finials come off of it and the shape and the length of all of those finials. The complex side is you'll get that, and you might have 20 or 30 fibres all stacked on each other. We've actually got to measure and count every one of those, even though they're stacked and all placed all over, and they might be mixed and embedded with other types of fibres that are non-hazardous. So we have to be able to identify that, measure each length of it, and then count it, because a pass or a fail works on how long it is, how many they are, and the type and consistency of that fibre.
Can it discriminate between the three different types of asbestos?
We can, but we're not going to market with that.
Right.
Because at this point there's no value in that.
Yeah.
And all that does is slow down the processing
yeah.
time.
Yeah.
Okay, so as it says, it's patented. In this microscope, and a little bit more about the history, we actually started off with a standard off-the-shelf microscope from one of the big name brands. We spent a year of our time wasted on it, working out how to make it to work for brand X. Then we worked out that the optics were different on it. The controllers and the motors, stepper motors, were all different, and every time we had a different model, different brand, all of our algorithms changed, and it didn't work. So to solve that, we developed our own microscope from scratch, and this is built here in Adelaide. A lot of the components are now subcontracted out to overseas, but it all came from, and we copied the raw design from the basic microscope that you find in any high school that they buy for about $500. So we've copied that concept of a microscope. We've used the same level of optics as a $500 microscope. Compared to the big brands, this microscope from a big brand starts at around $40,000 a unit and cannot do any more than 20% of the capability of this unit. We've got built into this microscope a Jetson computer. We've also got 5G, Wi-Fi, Bluetooth, runs on a DC power source that can be plugged in out of any computer laptop, can run off USB, so it can take as 5-volt USB supply, it's portable, robust, and not too heavy. You know, just pick it up one hand, no problems. It's patented. We've actually got 2 patents on it. The other patent we have is this, which is a macro imager. So most microscopes only look at things once. What we do is, as part of a validation process, we check to see if the slide's been prepared properly, that it doesn't have bubbles or contaminants or anything like that, and we do that on a macro imaging, so a large view image, because it can quickly analyse if it's right, and part of it, it also does the assessment to see where the largest concentrations of fibres are actually on the cloth. So we go to that first, because we want to know if we're going to get a bad result. We don't want to count squares if we don't have to, if there's nothing there. So we're charging $15 US for an analyst. These numbers up there are ultra conservative. So one microscope, if it only does 10 samples a day, will earn us $37,500 a year, and that's only if it works for 240 days of a year, and it only does 10 samples a day. The unit is actually capable, without an automatic prep loader and without an automatic stage loader, a human can operate this into 600 samples a day. if we go to an automated slide preparation and an automated slide loader, we can do it in excess of 3,000 samples a day. And we're currently working with an organisation on those other two devices that they've developed to integrate it into the scope.
What sort of market are you looking at to cater for that sort of thing?
Global.
Global market?
Global market,
Yeah, I'm just trying to think what industry.
what industry, anywhere that currently that analyses asbestos,
Yeah.
that's our initial product or our beachhead product to market.
Yeah.
I think I've got something that tells me, might have been back further. No, it's not on there, it's no further
I know the
forward.
construction industry is a big one.
Construction industry is probably one of the major players, but there's also, if you look at Netherlands, it is mandatory to monitor your own house, well, annually, if you have asbestos installed. Mandatory. So every building in Netherlands, it is mandatory that if you don't remove it, every year you have to have it monitored and analysed for the presence of, to find out if the, say it's a roof sheet, is starting to flake and spread the fibres out. And that's law. And there's other countries that are mandatory having all asbestos removed, regardless. There's some governments are subsidising that process, and they'll give you 50 to 60, roughly equal to $1,000 Australian to remove it by a given date. If you don't do it by that date, you have to pay for it yourself. So the legislation in some countries is getting very stringent on this because of the large impact it has to health. Okay, we also have, we've developed what we call a management suite. So it's just a software system that populates all of the answers and the client's name, the site details, the locations of where all that information goes to make it easy. We've also linked it up with a mobile phone, so the person originally who goes and does the air sample on site, when they place the air sample, they can take their mobile phone, click it on, the GPS coordinates and everything locate down to say where it was exactly by GPS coordinates, date, times, minutes that the filter was on, scans to check that the filter monitoring unit itself is in calibration, and loads all that data and won't let them proceed if it's out of calibration. And we've built that into the scope too.
So it's a standard collection
It's a standard
device
collection
that you
device.
use.
Yeah.
So, but your software is about recording the location of
Location,
that part of it.
times,
Yeah.
so all the, it saves a person typing in, I've just gone to
Yeah.
site ABC on this road at this time, and I turned it on for this amount of period, and then I turned it off on that, and I've used filter sample serial number this, and airflow meter serial number this. So you just do the scan of your phone, scan the barcode,
Okay.
pre-populates all that data, and that all goes back in, so everything's accurate, so it's chain of custody.
Excellent.
Is anybody knowingly using asbestos now?
Yes,
Oh, they are.
Yeah.
They're allowed to.
our new hospital has it.
The RAH or
The new RAH
new
has had
RAH,
asbestos put into it,
Yeah.
not knowingly, or
Oh.
not against, it was against the contract. The
Yeah.
people that installed it didn't know they bought it, but it was integrated into the sheeting and cladding that they brought out of China.
right, so somebody's still manufacturing it.
It
Oh,
is still
the
manufactured
Russians,
globally,
the
except for in
Chinese.
Australia.
Well, China's disposing waste by building it into products and selling it without telling you.
China,
Oh.
Russia, there's several of them that are producing this and integrating it in products at, at least 50 times more than it was when we banned it. That's
So
how
they're
much the
removing it.
consumption rate has gone up, not down. We're one of the few countries that's banned it. It still sneaks its way into products that we don't know about. So that's the software in the back end, so it's a billing system and all the normal stuff for just general reporting and how you make money, but also to make it easier for the clients and their integration. And this is our conservative time. It says that it takes 3 minutes to do it. It actually takes us 55 seconds. If we say 3 minutes, we're actually saying we're doing all 5,000 fields of view. We do roughly 200 fields of view because in other countries the standard is 200 fields of view. In Australia it's 100, so we set it all at 200 for our sampling. We've said training, it's about 3 hours. It's not that long, but some people take a little bit longer to actually understand it.
The weeks of training is how you would train a normal
And-
manual
and-
inspector.
A normal analyst actually
Yeah.
takes months
Right.
to be allowed to analyse a sample.
Right.
And they're usually graduates, and the churn rate is absolutely phenomenal. Because no one wants to sit there counting samples. So the churn is really, really high. And that, we talked earlier about fatigue, but litigation, that's the biggest thing. This actually takes litigation out of the equation, both sides of it, because you either know it's really there or you know it's really not. When you're only doing 100 samples out of 5,000, you don't really know that it's not there, ever. And again, everything we do has got chain of custody, whereas current process there is no chain of custody for the legal flow. Slides are disposed of typically within 3 to 4 weeks of a sample being taken, so your actual physical chain of custody is gone, and it's a tick sheet. So it has 100 squares on it, and it's got a tick or a cross on there to say if there was something in there or not in there. And that's your whole analyst currently.
But you would give a much more detailed report.
Ours gives us all of that, count, sample rate, everything, time, and we maintain the image forever. So because ours is photo imagery and very encrypted data, you can keep the image, we keep the image, it can be cloud stored, it can be on your computer, and it can still be in the microscope on the onboard computer. So chain of custody is good. We've already been talking to some of the biggest insurance companies in the world that they see the value of this, that laboratories that don't use this will have a higher insurance premium. Because they're a higher risk to them to be litigated against in the future. This was a trial we did in a hospital in New South Wales. We went there for a day or so to do the samples. We saved the contractor over $10,000. It's in the tens of thousands of dollars, but because where it was a remote site, there was no laboratories, they were driving several hours each way to find out, and in the meantime they had all these people there that couldn't work until the sample was come back as clear, it was safe to go and resume work on that site. We had another instance on a large mining site up in Queensland, and they were saving $100,000 an hour in lost time and lost production, just because they could get the result on site. The scope was sitting there, and they were able to do the analysis there and there.
Is this like sending the bird into the mine to see if the gas is down there?
A little bit smarter than the canary, but but it's real-time answers.
Yeah.
Whereas the current system, it takes days, if not weeks, to get an answer. This will give you an answer there and then, on the site.
So are you selling the machine or just providing the service of analysis at this point?
We sell it. We don't provide, sorry. We've got, our model is, we sell them the bit of hardware,
Yeah.
and every time they use it, they pay us.
Right.
Because we are there. Someone else physically puts it under, but our AI and software is doing the
And
analysis.
then you can maintain it and update it and
Yeah,
all
so
that.
yeah, it's a lifelong agreement. We're always updating it, and we've got other verticals that will come into it that they'll have the option to take on and add on to that vertical to increase our revenue stream. But to give you an idea, somewhere between $50 and $65 per analysis is the current rate in Australia. We're charging 15.
$15 US.
Yeah.
Yeah, yeah.
Well, sorry, $15 in Australia, 15 US everywhere else.
Oh, you're too nice to us.
Yeah. So again, the Australians don't like paying for things.
So you just wait until someone within the building thinks that we need to have something tested and then they contact you, is that how? Or is it a health
we-
and safety thing, or how does it happen?
No, it's mandatory by law that
Every building?
everyone that they're working on must be tested and monitored
But what about
throughout.
the buildings that are in existence now?
If someone goes and does work or modification to that building or demolition, it's mandatory, they must test it, even in your own home. So if you've got a house that's got asbestos walls or asbestos roof sheeting or asbestos tiles in your bathroom, and yes, most older houses, the underside of the tiles is all made out of asbestos, and you'll be surprised how many products in your house, if you've got a house pre-1970 or pre-1980, that has asbestos products in it.
So
There'll be-
in fencing, like I do, we have an asbestos fence, we know it's asbestos. We'll call the guys from asbestos to come and remove it. They'll bring the air monitor guys
Correct.
and they'll set up their air monitoring thing on a tripod while they're removing all the sheets and their protective wear. And then they'll give the result to whoever.
Yeah.
And then it all gets logged and then I'll go in and put the new fence up.
Correct.
But the asbestos is gone and all the safety precautions are.
And that probably causes a 2 to 3 day delay
Yeah.
on your job,
It is.
typically.
It's no big deal.
It's not a big deal,
It's
but
allowed for.
it's allowed for, but if it was happened there and then, how many more jobs
Yeah.
could you do and how more efficient could you be?
It slows things down a little bit.
Correct. And that costs by 10,000 of you
Yeah.
around the globe doing the same job every day. How much does that cost in the global economy?
It adds another third to the cost of the installation of the
Exactly
fence.
right.
Yeah.
Okay. We've actually been working with this gentleman. He's brilliant. Mike is he sits on the advisory and standards board for Australia on how you do asbestos monitoring and that. So Mike's worked with us in his laboratories proving it, that what our system works. So he's gave us some good advice, good learnings as well. We've actually worked with about 5 different laboratory groups within the country to understand their processes and procedures and how they do things and look at the things that we were missing in our understanding of it. And this guy is known in Australia as the best in the field of this area and actually sits on the standards board.
So does an individual Marvin instance need to be like calibrated every year or checked or something? Or?
Even better, Marvin calibrates itself every day before you use it.
Okay.
And it checks its own serials numbers, it checks everything. have this accredited, there's other things that can be accredited as a human, which will just lead to changing of the law eventually of how we determine what is good and what's bad. Okay, we talked a little bit on this earlier, so it's traceable with all your barcodes, samples are digitally stored. We keep the raw image, but we also keep all of the breakdowns or filtered images as well. Again, so every step is validated and no data is ever lost or corrupted. Again, to keep the chain of custody. It's simple. Everything's just works on Software Wizard, so everything auto-populates. As you heard, the speed is incredibly quick compared to a human, and then with the accuracy well beyond what a human can do. When we put this up for validation, it got a perfect score. It is, it's good. We've got lots of other verticals that we're using, going to market soon for. In a meeting earlier today that we're just trying to raise, and it sounds like we did an extra $2.5 million US to accelerate those verticals.
This way of electronic logging and all that would stop the problem where it used to happen before, where they were saying they were sampling, testing samples and not doing them.
Exactly right. And that's why we also put the app in on the phone to get the GPS coordinates, because a lot of builders would pick up the air monitor and then walk it to the front gate so they could get clearance quicker, and then just put it back by the time the guy came to, because they knew he was coming at 3 o'clock or whatever time to pick it up and take it to a lab, and to bypass the system and not hold the site up for 3 days or 4 days or a week sometimes. So we just take the air monitor and literally put it outside the front gate. And it still happens currently.
Basically the power station, Osborne Power Station, there the asbestos used to fall down constantly, and the sweepers would be sweeping up every day.
The best thing you could do.
and they used to have air monitors in there,
Yeah.
and they never ever come back with a result.
No. Oh, it always would have been bad, especially that building.
Yeah,
because it was just flaking.
That's
It would have, the whole atmosphere would have been contaminated at all times.
I've still got photos of trailer loads of asbestos that were just loose and everywhere.
Since you worked in it, there is a site that's Hatchery runs it. Please register yourself, or on the Safe Work Safe site. There is a register for anyone who's ever worked with it or been in the environment. Register.
Okay.
Please register, because if anything ever does happen to your health and you're on that site, your family will get immediate compensation.
It's often lots of years later, isn't it?
Yeah, it's 25 to 30 years later before it becomes relevant, but that's not always the case. There was a guy in the AMP building, what was it, 1 King William Street. They did a renovation on one floor, and he was a clerk on a different floor to what the renovation was done. 2 years later, he got mesothelioma and died within another 2 years. Never ever drilled a hole in it, lifted it, or done anything with it in his life. It just came through the air conditioning ducts. And he didn't get compensation because he wasn't deemed to have been in the work area. But there is a site, there is a registry. If you've ever worked with it, drilled a hole in it at home or wherever, register. And at least, because if you're registered, they hold the money, because the money's not an unlimited bucket. But if your name's on the registry and if something ever happens to you, you get some of that money that's in the bucket. And it's not widely known. And in fact, of all places, I found out about it in Manila last year in October.
Wow.
So what's the name of the site?
It's either on ADRI, so asbestos disease, and it's also on Safe Work.
Okay.
So, all the Safe Work groups around the country. But yeah, I found out in Manila
Mm.
about it, and I've worked with it, and I was exposed to it for many years. I came from a trade background, so it was quite normal to play with it all the time. Okay. So this is a bit of an old slide, I haven't updated it. So at that stage we'd sold about 10 units, so about $15,000 a unit. We've now got one starting at the old Royal Adelaide Hospital in about 2 weeks' time. We believe that one unit will be generating us somewhere around $2,000 to $3,000 a day profit from one unit. That's how many analysis they need to do on that building. In that building, all the reinforcing steel in the concrete was asbestos coated.
Oh my God.
So not only were the walls with it and all the pipes had asbestos rope around it all everywhere, even the rebar in the walls and in the concrete floors was all covered in asbestos.
What was the reason for that? Any
Fire
idea?
rating.
Oh, okay.
It was a cheap way of fire rating. Don't know why you want to fire rate a bit of steel in a bit of concrete, but it's a different story. But they also sprayed all of the ceilings with it, again, for the fire rating. It was roughly about that thick. Okay. We talked about roughly, this is our channel market, so we're setting up distributors. We're not selling it ourselves. We're not a sales company, we're a technology company. So we're going to people who are in the industry, who do this for a living. They either sell the air filters currently to people that do the analysis. In Europe, we're going to the people who make the air filters, the monitoring units. They're going to be our distributor in the UK. Netherlands, we've actually got, of all people, the asbestos lawyer for the Netherlands who's distributing. Next week, we're in America to set up our distributors in America. In Australia, we have a training organisation that trains people in how to do air monitoring and air sampling with asbestos, and also sell the filter elements. So we're using distributors or channel sales partners, and we're looking after it too.
Yeah, not bad.
We're making sure we look after them. There's quite a bit of money in there for us. Giving you globally, there's at least 90 million samples done every year. At least. And from all records, it's got I think it's about 20 or 30% CAGR, so compound annual growth per year. So a lot. The problem's not getting smaller, the problem's getting bigger. And we talked about it before, so there was a typical another brand, and I should blank out the brand. Ignore that, you can't see them, but it's not just them, it's anyone. They're all about the same dollars. And then we've got ours with our price point. And you can see ours has got some unique features which are different to everyone else's, and it's a lot simpler and a lot cheaper. We actually talked to SA Water. Their one over there was a $250,000 microscope. Another little fact, and it will give you an idea of one of the verticals that we're going into. Currently, daily we see about 13 pathogens go through our water supply every day. And that's from, I think it's around 300 monitoring points around the state, where the main pumping stations are, and we have 13 pathogens that go through there. So every day we have someone to go to all of those 300 sites, grab a physical bit of cloth, so a membrane sample, and drive it back to Adelaide. Right into Victoria Square to where the laboratory is, and then we hand it to the group of 5 analysts. 5. And their job is, they have to analyse every one of those samples. How long does that take? So by the time that water's gone through with the contaminant and you've drunk it, you've got sick, and you've got cured, they know what caused it. Huh?
Too late.
Too late. That's our current system. So it's also the inroad to one of our next big verticals that we'll be going into, which is water quality. And putting an inline live, so it'll be, won't look like this, but it'll have all the brains of that and it'll actually sit in the water pipe and do that automatically. And now, again, globally, water quality is a major issue all around the world. Again, we have partnered up. The stage here, we've used Aprodyne have been one of our technology partners in helping us do all the machining and help of the products here and a bit of the design. And we've also worked a bit with Motherson's Innovation, which is the old company that used to make the rear vision mirrors on your car out at Lonsdale. So they used to make rear vision mirrors for Holdens and Mitsubishi, Chrysler, Toyota, and they still actually do, but just not for the Australian market. Yeah, who are they? Different story. Okay, this is the revenue opportunities that we're just starting to realise. So by the end of this year, we're expecting to make just over $2.25 million profit. And our whole team is 6 people. Next year, we're talking about nearly $14 million profit. And the year after, we're talking $30 million. These are ultra conservative numbers. And I mean very, very conservative numbers. In fact, if I get the deal across the line, that I think I will next year will be in excess of $300 million.
Very quick growth rate.
Yes, but it's scalable because we're not the manufacturer. It's software to us. That's why we're looking at manufacturing partners in regions. So it's quick to market. It also reduces our shipping costs. One of these in this box, if I've got to ship it to Europe, that's $600 just to get it there, and for 4 weeks.
Well, it's taken 4 years to get to this point.
It's a 4-year journey, and look, so far we've spent in excess of $1 million on this, and we've been self-funded. So this is all from angel investors. Some people have put in $20,000, some people have put in $100,000. The state government gave us $400,000. Well, sorry, they've committed to $400,000. They've given us $100,000.
The current state government or previous?
The current one gave us the money. The previous one agreed to it. So now we'll start to talk about our verticals. The asbestos market globally is only $4.7 billion a year currently, and again that's growing at about 30%, 25 to 30% compound annual growth. The water, air quality and beverage, beer, soft drink, bottled water, that alone is $48 billion a year and growing.
Well, that could include water used in other food manufacturing.
Yeah, it's multiple uses, and we're also able to do particulates, so it can be flour. So the flour in the flour mill, or so there's lots, because we're able to also do particulates. Health is our big one. We've actually met with some people today, and we're talking about what we need to do to get into health. We believe we're about, if we commit the funds that we need to commit to do that, we're probably 18 months away going into that vertical of $60 billion a year.
So does that mean you'd be doing blood analysis?
We won't go into blood, no.
Too many
We probably
regulations.
go into tissue
Yeah.
rather than blood. We could go into blood, and there's no reason why we couldn't go into it. It's just there's a lot of things out there similar, doing similar things in the blood area, and blood, because it is actually critical to health, the approvals and the cost approval and the time for that to happen is typically around 7 years. We don't see that's a priority at this point in time. We are working with the Asbestos Disease Group. They've agreed to give us access to their 50-year database and tissue samples of all people that have contracted it, so all the samples out the lungs. And we're going to look at that to do quicker prognosis and analysis. So the tissue sample takes the analyst roughly around 4 hours to analyse if that
From a biopsy or whatever.
from the biopsy part.
Yeah.
There's about 4 hours of work they need to do on that.
Yeah.
And it's really, and everyone we've spoken to that actually does that, gets a lot of fatigue and a lot of headaches from doing it, because it's 4 hours to do one constantly under the scope. So we see that as something that we can help in the health sector, but it's not, we're going to diagnose something, we're going to look at how we do the more on the research side of it first. Because the diagnosis size, which is class 1 medical, is a really hard road to market. One of our investors is in that sector, and you may have heard of them, Life Whisperer or Prestogen, who do embryo for IVF. They're in that category, and I can tell you they've spent a small fortune to get there. And gotten very close several times to becoming bankrupt along the journey, but they've pulled through it, and now their product's actually to market and they're classified in that area, but it's caused them a lot of pain. They use similar algorithms to us in the deep tech type algorithms and computer vision, and that's why we're aligned together. We work and share information, but we both use computer vision, we both use a bit of deep learning and a bit of machine code learning in how we get to these points.
So, convolutional neural networks? Yeah.
But this gives you an idea of the market that we want to disrupt. We're not going to earn all that. That's the market size. But I think anyone would be happy with 5-6% of the share of that market.
So your patents are not around the computer vision, because that already exists. It's all the other stuff you've done.
It's also in and around the computer vision, yes, and the algorithm of the computer vision.
Oh, okay.
So we have found a unique way of doing that, that we are able to, and we've got patent accepted on that.
Cool.
Yeah, and it wasn't easy. We've still got a couple other patents we're waiting for, but we've got now two to approve. Okay, well, let's talk about CAGR. There you are. That gives you roughly the breakdown of CAGR per market, and the industries and the sectors and segments of what that means. So we're saying that frontier microscopy, once we get into all of those verticals and markets, we're potentially a $1 billion a year business.
So when are you going public or not?
We've done very, very well to protect the equity.
Okay.
Extremely well to protect the equity. In fact, yeah, we've only given away 26% of the pie, all up to get to where we have.
Correct.
And that's the smart way. We see too many entrepreneurs, inventors, startups getting through naivety, not understanding, and cash strapped, giving away 50, 60, and even 80% of the pie.
And then they get kicked out.
And then they get kicked out. There's been numerous out of ThinkLab that have lost their businesses or forced to the wall by their investors, so they took the IP over.
Yeah.
So there's a lot of sharks out there.
Well, the classic public one was Unity Wi-Fi.
Yes.
Yeah, Shay and Sasha.
Yep.
You know, built it from the ground. Investors
Yeah,
took
they're
over,
gone.
and as CEOs, they were said goodbye.
We don't need you anymore.
Yeah.
And look, what, you know, Sasha knows what I do. I work with businesses and develop businesses and back shares in businesses, but part of what I do is for other investors or venture capitalists. I actually go into those businesses and make those decisions to get rid of the founders where they're not playing games. Yes, I'm technical, but I'm also the business head. And yeah, part of what I do with numerous businesses, and I would go in there and I've just actually done one the last week, a hostile takeover of the company.
Well, sometimes the founders are holding it back, aren't they?
Most times, look, behaviour is the worst enemy of any business. So if you, and the businesses I invest in, it's not just about the widget, the service, the tech, it's about the person. If the person hasn't got the skills or the behaviour traits that are able to change to be a good business person, well then I either don't go in or I go in on the pretense that they're going. And that's business. And yeah, you mentioned the real classic one. There's several others. Because I also mentor a Think Lab, I also mentor for the E-Challenge, and numerous other things, and I see it way too often. There's a lot of people out there that don't have scruples.
What's the E-Challenge?
Entrepreneurs Challenge. Okay, that's probably, there's that sample or data at the bottom is really interesting. The 80 million square metres of asbestos. That's Netherlands only of installed asbestos. Another little project that Jordan and I and another group are working on, and I believe we're going to get the grant through from United Nations, is to do satellite imagery of installed asbestos. So we probably enough one night we borrowed someone's satellite and took an image over in the northern hemisphere, and then applied our computer vision into it, and we're able to see the change in colouring of installed asbestos.
Is that multispectral analysis?
Yeah. So we're able to do that. So we're getting a grant to do it from the United Nations and the World Health to do where the tsunami was. What was it, 10, 15 years ago? Because what happened there? Yeah. Not Fukushima,
The Boxing Day.
Boxing Day.
Yeah, in Asia. Yeah.
In
So in
Thailand.
that one, all the buildings were asbestos. So all the asbestos got washed up X amount of kilometres.
And broken up.
And broken up and smashed into all the ground. Then what the government did to quickly expedite putting up tents and everything else was got the bulldozers out and pushed it out into the jungle and the forestry and the plantation areas.
Great.
So what they're looking at us to do is to come up with a solution to find out how much of it is out and where it is and map it so they can uncontaminate that land for growing vegetables and everything else. So
And you
it
think
takes
you
it
can
out of
do
the food chain.
Satellite
Yeah.
analysis.
And that'll be all
Yeah.
done by satellite analysis.
Yeah. Wow, cool.
So it's just another little project that we're going into. Little. We've got to stop doing stuff like this. It's amazing what you come up with over a few beers at a pub with the wrong group of people, but it's all possible. And yeah, that's looking at forecasts when we start to go for total analysis, and again, a little bit ultra conservative in what we're talking about now to where this was probably about 12 months ago I produced this, and we've suddenly realised they were extremely conservative numbers.
So a patent gives you, is it 17 years of production? 20 years, okay.
Which I think is long enough. Yeah, we've got a great team. Obviously we've got Jordan, the founder, South Australia Young Achiever of the Year as well for 2018. We've got Stan Jensen, who was the CFO globally of Grundfos Pumps, a multi-trillion-dollar company. Got myself, dumb electrician, corporate fixer, whatever.
Yeah.
So what's CCO?
Chief Commercial.
That title, Chief Commercialisation Officer. I've never heard of it before. That's just something Jordan wanted to give me. I don't know why.
Oh, just for the minutes.
Jack of all trades, master of none. Dumb electrician will do. Then we've got Gabor, he's one of our developers. Stephen Gruber, who was the person that originally, he does this for a living, actually counts samples, and that's where